Okay, at this point, we have dealt with the ratios of similar two-dimensional figures. Now we're going to talk about the ratios of similar three-dimensional figures, similar solids. So let's start with just our scale factor. So we want to know the scale factor between these two figures. So we have 2 over 5. 2 miles over 5 miles. Our units cancel since we have the same units for both. So it's just 2 over 5. We could write it as a ratio 2:5. Can't reduce that anymore. So to understand the way that this works for all similar solids, we're going to give a letter to each of these. So let's call this figure A and this figure B. Let's go down and fill this in our chart. So in our chart, for our scale factor, we're going to have A to B. Now we have to find the ratio of our surface areas. So let's go back up here. We're going to need to calculate our surface areas so that we know for a prism, our surface area is equal to 2 times the area of the base. Let's double check. We do have a regular base, so n times the area of a face. In this problem, it's easy because we have cubes. So we have 2 times the area of our base is 2 times 2. We have 4 sides to our base, and each of our faces is also going to be 2 times 2. This is a cube, so we have 6 faces that are all the same. So we have 8 plus 16 gives me 24 miles squared. Surface area of my other cube, again, 2 times the area of my base plus n times the area of a face. In this case, our base is 5 times 5. We have 4 sides to our square base, and the area of a face is also going to be 5 times 5. Once again, we're dealing with cubes here. So 5 times 5 is 25. Which gives us 150 miles squared for our surface area. Now let's figure out what that ratio is. So if we have 24 miles squared over 150 miles squared, let's reduce this fraction. When we reduce it, our units cancel out since it's miles squared divided by miles squared. And we get a fraction of 4 over 25. So 4 to 25. Now let's take a look. How do I get from 2 to 4? Well, I square it. So this is going to be a squared. And how do I get from 5 to 25? I also square it. So this is going to be b squared. Let's just fill that in our table. And last but not least, we are going to deal with the volume ratios. So let's calculate our volume. We know that the volume is equal to the area of my base times my height. So in this case, my base is a square, so length times width times the height of my whole solid. So for the one on the left, I'm going to have 2 times 2 times 2. 2 times 2 is 4, times 2 is 8 miles cubed. Once again, the area of my base times the height of my prism. For the other solid, it's 5 times 5 times 5. So my volume here is 125 miles cubed. Now let's go up here and work with my ratio. So we have 8 miles cubed over 125 miles cubed. Miles cubed cancels out. This fraction cannot be reduced, so it's just 8 over 125. 8 to 125. And how do we get from 2 to 8? Well, take a look at what we did. 2 times 2 times 2. So that would be a cubed. 5 times 5 times 5 gave me 125. So this is b cubed. I'm just going to finish filling in my table down here. So for the ratio of my volumes, I'm going to cube both of my scale factor numbers. And just one last point that I want to make. These exponents should make sense because when we're dealing with volume, we're dealing with units cubed, 3 dimensions. When we're dealing with surface area, we're dealing with areas, units squared, 2 dimensions. When we're dealing with scale factors, we're dealing with just units, 1 dimension. Hopefully this helps you.